Okay, welcome. For this deep dive, you sent us a whole stack of sources, all looking ahead at advanced air mobility, scaled drone operations. And the really interesting thing we pulled out is this. The main roadblock, surprisingly maybe, isn't the drone tech itself. We have incredible aircraft already. The real holdup seems to be the intelligent infrastructure needed to actually support flying hundreds, maybe thousands of these things safely.
That's exactly right. Current operations are just sort of stuck. Everything's built on these expensive one pilot per drone models. And navigating this patchwork of FAA waivers and exemptions, it just eats up resources. It simply doesn't scale up for big commercial services.
Right. So the whole way we think about operations has to change fundamentally. We need to move towards this drone as a service idea, Des, where one person isn't actively flying, but they're managing a whole fleet of autonomous drones remotely.
Yeah, the human role shifts from active pilot to more of a supervisory manager, almost like an air traffic controller just for their own vehicles.
Okay, but managing fleets like that, I mean, can you really trust the software to replace human eyes, human hands, especially beyond visual line of sight?
Well, it really hinges on having a super dense physical support system on the ground. They call them public infrastructure network nodes, or PANs. Think of them like specialized smart cell towers, but for the sky.
Mm.
They're these modular hubs. They provide really reliable power, high-speed machine-to-machine networks, and critically, a dense layer of sensors, things like 4D radar, LiDAR.
For continuous surveillance.
Exactly.
Yeah.
That dense coverage is absolutely essential to enable safe beyond visual line of sight, or BVLOS, flights. You just can't do it otherwise.
We saw that Lake Travis Intelligent Infrastructure Economic Zone mentioned as a real-world example. They've got that continuous physical coverage set up. But the amount of data coming off those sensors, the computing power needed to process it all in real time must be enormous, predicting tiny wind shifts, microweather.
Yeah, and that's where the digital side comes into what they call the active digital twin. It's not just a static map. It's a dynamic virtual copy of the actual airspace, constantly updated with live sensor data from all those PINs on the ground.
Okay, so it's modeling everything live.
Yes, it's the engine that runs predictive flight paths, optimizes routes in real time, manages the whole fleet. It's constantly adapting.
Constantly changing and self-optimizing. That sounds like a potential nightmare for regulators. How does the FAA even approve something like that?
Well, that regulatory piece is critical, you're right. And the FAA is proposing a really necessary shift here. They're looking to move away from the slow, case-by-case enablement through exemption.
Which is the current patchwork system.
Right. Towards clear enablement by rule. That's through proposed new regulations, Parts 108 and 146. This would create a predictable pathway for these scaled operations and formally recognize these automated data service providers, the ones running the digital twins.
Okay, that makes sense. But building all those PANNs, the network, the data centers, that's a massive upfront cost. How does that get funded?
That ties back to those intelligent infrastructure economic zones, the IIEZs. They often operate as public-private partnerships, P3s, and they use models like build, operate, transfer. Crucially, their revenue isn't just from flight fees. They pull in money from data monetization, connectivity services, operational efficiencies they create. It makes the whole thing more attractive to outside investors, not just aviation companies.
Right, and this is where it gets really fascinating, I think, for you listening. You start to realize this multi-billion-dollar future of air taxis and drone delivery. It's less constrained by, say, battery physics or software code, and more by something much more mundane, property law.
Absolutely. The unsung heroes here aren't necessarily the aerospace engineers anymore.
Who is it then?
It's the real estate developers, the investors, the lawyers. They're the ones needed to secure the physical rights of way on the ground for the infrastructure.
And what binds it all together legally?
The ultimate linchpin, the thing that makes a seamless network possible, is the aviation easement. And this is the slow part. It's a human-led process, negotiating legal agreements, parcel by parcel, with individual property owners.
Just to get the right to fly over.
Exactly, to get the right for unobstructed air passage and also to protect the operators from future claims about noise or vibration. Without securing these easements across an entire operational area, the whole idea of a frictionless, interconnected system, it just doesn't work. We've sort of solved the flying part. It's the ground-level paperwork that's the challenge now.
So pulling it all together then, scaled AM, this future we're talking about, it demands this synchronized effort across, what, 4 layers? You've got the technology, the PANs, and the digital twin. the regulatory clarity, those new FAA rules,
Hmm.
the commercial funding, the IEZs and P3s, and then, maybe most critically, this ground level legal foundation built on easements.
Which leads to, I think, an interesting final thought for you to consider. If the biggest thing holding back global air mobility right now is literally getting legal paperwork signed by individual property owners, what other huge transformative infrastructure projects out there today, maybe things like high-speed rail or even rolling out fiber optic internet, are similarly stuck? Not because the technology isn't ready, not because of physics or software, but because these really complex ground-level legal and commercial negotiations really makes you think about the power of these non-technical factors.